Yeah, hi friends, my name is Chandan and welcome back to my channel Energy and Environment Education. Friends, this is the second part of the chapter HVAC and refrigeration system. The first part I have already discussed. I have posted the video on the first part, and this is the second part of the chapter, friends. Hopefully, you must have gone through the first part. If not yet, please go through the first part first and then come back to the second part, part B of this chapter. I have discussed a lot many points in the first part, and I'm also going to discuss good number of points in the second part as well, friends. And this points will be helpful for you, I hope, for preparing for your exam in this year or in coming years, friends. So all those aspirants who are looking forward to take exam in for energy auditor exam or energy manager exam this year or in coming years, for them this chapter is going to be very important for them to prepare. And also the points that I have discussed, the highlighted points, the key points, or as for the exam questions are concerned, those things I have discussed in the for part A, and also going to discuss in part B, friends. So hopefully this will help you to prepare for your exams, and friends. So please keep watching the video till the end, and I hope this particular video will help you somehow in your exam preparation, friends. So without wasting further time, let's start the video, friends. So let's the content first, friends. I'm going to start with the types of compressors first, and also I'm going to explain you the different refrigerant properties, then the performance assessment, and the COP, what is COP all about, and also the energy saving opportunities I'm going to explain you, and also the efficient operation and maintenance of the refrigerant system, friends. These things I'm going to explain you basically in this particular video, and it's very important. These are all important topics which can be very important for you as far as the exam is concerned, friends. So let's start with the first part, that is the compressor types, friends. So as far as the compressor is concerned, friends, it's very important as far as the compressor based refrigeration system concerned, friends. But I'm not going to explain in detail here in this particular video about the compressor, because I've already made a separate videos on compressors. So if you want to understand what the compressor all about is, and also the application of the compressors, the working principle of the different type of compressors, so you can go through those videos that I've already made and posted on this channel, friends. So I'm not going to explain you in detail here in this particular video, friends, about the compressors. But for the time being only, you must know the different type of compressors which are used in the compressor based refrigeration system, friends. The first type of compressors are the centrifugal compressors. The detail you can find in the chapter that I have posted on compressors. Again, the second type of compressors, which is the reciprocating compressors. The third type of compressor is the screw compressors, and the fourth type is the small compressors, friends. So basically these are the four different type of compressors which are very important for you to understand. And as far as the exam is concerned, friends, in this chapter they may not ask you about the compressors, because already there is a separate chapter which is based on the compressors. So you may not expect too many long answer type questions or explanatory type questions from this particular part of the chapter on compressors, friends. From compressor chapter you may expect too many questions about the working principles of of the compressors, also the application of the compressors. So those things you may expect from that chapter, but not from this chapter. But yes, some numerical based questions you may expect to have from this particular compressor part of the chapter, friends. So I'm not going to explain you again, I said. So those things you can find it out easily in the video that I've already posted on the compressors. And for the time being only, you should understand the different type of compressors which are very important as far as the exams are concerned, friends. So as far this part of the chapter is concerned, friends, the properties of commonly used refrigerants. So you must understand, it's not possible to by heart all these numbers as far as the exam is concerned. But they may ask you to name the different type of refrigerants. So in that case, you must remember the different type of refrigerant, which is the R11, R12, R22, R502, R7. So these are different type of refrigerants. So they may ask you to highlight or name at least 3 to 4 different type of refrigerants. In that case, you must remember these names, friends. Secondly, this terminologies like boiling point, freezing point, vapor pressure, vapor volume, enthalpy, all these terminologies are important. So they may ask you to define this type of, they may ask you to define what is boiling point, what is freezing point, or what is vapor pressure, vapor volume, or enthalpy. So this terminology is also important for you to understand, and you can you should know the definition of these different terminologies also, friends. Again, one more thing is important is the units, like for vapor pressure it is kilopascal or meter cube per kg for vapor volume. Then for enthalpy you have kilojoule per joule per kg. So for all these different units are also important as far as the exam is concerned. So they may ask you to name the different refrigerants. They may ask you different terminologies to explain, and also the units. These numbers are not so important, and it's not possible also to by heart, but still you must understand these numbers, and at least some idea you must be having about these numbers. Not exactly the number, but at least the idea you must be having about these numbers, friends. So this is very important part of chapter, and they may ask you in exam in different ways, basically short answer type questions, or also for one word answer type question also, friends, can come from this part of chapter, friends. So as far as the performance assessment is concerned, friends, this part of the chapter is very important as far as the exam is concerned, and this particular formula is also very important for you to remember and for you to understand, friends. So the formula says TR equals to Q into CP into TI minus T0 by 3024. So basically, you see the TI is the tonnage, and Q is the mass flow rate of the coolant in kg per hour. CP is the coolant specific heat in kilocalorie per kg per degree centigrade. TI is the inlet temperature of coolant to evaporator in chiller, and TO is the outlet temperature of coolant from evaporator in degrees centigrade, friends. So this is the important formula that you must understand, and also you must remember as far as I am concerned. You may expect part of long answer questions or short answer questions. Also you may expect a number of numericals based on this particular formula, friends. So this particular formula is very important for you to understand and to remember as far as I am concerned, friends. Again comes the another formula which is very important, and also terminology which is very important for you to remember as far as I am concerned. The COP, the coefficient of performance. This is a very important formula. COP Carnot equals to TE divided by Tc minus Te, where the Te is equals to the evaporator temperature and the condenser temperature Tc. So this is a very important formula. They may ask you to find the COP and also define COP. So these two things you must understand and remember as far as I am concerned, friends. So basically you may expect to have number of questions, basically shorter set of questions, or uh, part of longer set of questions, or also numerical based questions based on this formula, friends, and also the reference of the COP, friends. Also, this is an important formula, friends, of COP. So earlier in the last slide, you have seen one formula of COP. This is another formula of COP where the COP is calculated as a ratio of cooling effect in terms of kilowatt divided by power input to compressor in terms of kilowatt. So this is also important formula, friends. So you may expect to have the numericals based on both the different type of formulas of COP and the definition of COP, friends. So you must remember the definition of COP and the expression on COP, and also the formulas, the two formulas. So you may expect to have different type of numericals, short answer questions, and also the long answer questions, friends. So you may expect to have different type of questions based on this type of formulas and the explanation of COP, friends. So the overall energy consumption in the case of compressor-based refrigeration systems. So this is also an important point to be noted for your example point of view. Basically, there are four major areas you can see where the energy is consumed. First one is the compressor itself, where the major energy is consumed in the case of compressor-based refrigeration system. Second one is the chiller water pumps. Third one is the condenser water pumps, and the fourth one is the cooling tower fans. So these are the four areas where the major energy is consumed. So if you are asked to calculate the overall energy consumption, or some numericals is asked where the overall energy consumption is required to be calculated, so in that case you can consider all these four areas in the case of compressor based refrigeration system, friends. Now this is very important concept, you can say, or this table is also very important to understand for your example point of view, friends. So basically the effect of variation in evaporator temperature on the compressor power consumption. I mean how the compressor power consumption behaves with the increase or decrease in the evaporator temperature, friends. So just to have a concept in mind, basically you need to keep the evaporator temperature as high as possible. So if you see if the temperature is 5 degrees centigrade here, in that case the specific power consumption is 0.81, but as the temperature is lowered, so specific power consumption is increase. This means you should keep the evaporator temperature as high as possible. So if you keep the temperature high of the evaporator, in that case the specific power consumption will be less. If you see the increase in kilowatt per ton percentage, so as the temperature is lowered in the case of evaporator, so you should understand the uh, that what we are talking about here is the evaporator. So in the case of evaporator, you have to keep the temperature high as high as possible, and in that case, if you see if it is lowered, then in that case specific power consumption also gets increased, and the increase in kilowatt by tonnage also will be increased if you keep the temperature low. So as a 1 degree centigrade rise in evaporator temperature can help to save almost 3% on power consumption. This means if you want to conserve energy, if you want to keep the power consumption low as possible, so in that case you need to raise the temperature of the evaporator. I mean, as high as possible you can keep the evaporator temperature, friends. So more the temperature high you keep, less will be the power consumption, and specific power consumption also will be reduced, friends. So this is one important concept that you must understand. So you might get some questions based on this concept. Also, this table is very important for you to understand as far as the exams are concerned. And this particular concept, they may ask you as a fill in the blank also, like they may ask you to fill up the blank at 1 degree centigrade raise in evaporator temperature can help to save almost 3% on power consumption. So these two space can be blank, kept blank here, and they may ask you to fill it up, friends. So it's very important for you to understand this concept, and also as far as exams are concerned, it's very important, friends. Now, similar to the last slide, this is also an important concept for you to understand. Just the reverse of the last slide that you saw there. Here it is effect of variation in condenser temperature on the compressor power consumption. So it was there in the last slide we saw the evaporator temperature. Now it is the condenser temperature. So in the case of condenser, friends, the condensing temperature you can see if it is 26.7 degrees centigrade. So in that case, specific power consumption is 1.17. But if you increase the condensing temperature, so specific power consumption also increases, and there will be increase in the kilowatt by tonnage percentage also. 20.5 it is now, and it was 8.5. This means that you have to keep the condensing temperature as low as possible. So unlike the last slide where the evaporator temperature was kept as high as possible, here in the case of condensing temperature, or you can say in the case of condenser, you have to keep the temperature as low as possible, friends. This is also a very important concept. So you may expect to have some questions based on these two concepts. The last slide that I discussed, and this slide also is very important for you to understand as far as the exam is concerned, friends. So this is also important concept for you to understand, friends, and these are the concept is basically based on the last two slides that we saw, that is the evaporator temperature and the condenser temperature. So basically what we saw in the last two slides, that is we have to keep the evaporator temperature as high as possible and the condenser temperature as low as possible. Now if you see this particular table, in the normal condition the evaporator temperature is suppose 7.2, condenser temperature is 40.5, and the refrigeration capacity is 17.0, specific power consumption is 0.69. So what we see here in the normal condition, if it is the parameter that we see here, or if it is the number figures that we see here, so in the case like suppose if the condenser is kept dirty, so what happens if the dirty condenser is there, the temperature of the condenser will increase. Now what we saw in the last slide, that you have to keep the condenser temperature as low as possible, but in this case what happening, basically if the condenser is kept dirty, so the temperature increases, so you'll not get a better result here. So in this case what happens, the refrigerant capacity decreases, specific power consumption increases, and so is the increase in the kilowatt by tonnage percentage, that is 20.4% is increased. So basically you are not getting a good result here. Similarly, if you see that in the case of the evaporator, if the evaporator is kept dirty, if it is not maintained properly, then what happens, the evaporator temperature is decreased. So what we saw in the last slide, that the evaporator temperature is kept as high as possible, but in this case what we are saying is it is decreased here. And with that what is happening here, the refrigerant capacity further decreases, and also the specific power consumption is 0.82, and there will be also increase in the kilowatt by tonnage percentage, friends. So overall what we see here, that we have to keep the condenser as high as possible, I mean as low as possible, and the evaporator as high as possible. But in the case if it is kept dirty, so there will be opposite result. So therefore the maintenance of the evaporator and the condenser is very important as far as the energy consumption or energy conservation is concerned, friends. So this is a very important table for you to understand. and this concept also very important for you to understand. So they may ask you question related to this particular table as just to explain what is the effect of poor maintenance on the compressor power consumption. So in that case you can cite this table and explain the entire concept, friends. So this is very important for your exam is concerned, friends. So these are some of the energy saving opportunities, friends. So I'm not going to explain you in detail here, but just to see the listed points here. Basically, if you want to save energy in the case of refrigeration system, friends, so you can have the cold insulation and also building envelope into place. Building heat loads you need to minimize, and also process heat load minimization is there. Then you can have to keep the avoiding wastage like heat gains or loss of chilled water, idle flows. Frequent cleaning is also important. Rescaling is also important. So these are some of the steps that you can take and to save energy. So these are some of the energy or saving opportunities in the case of refrigeration system, friends. So I'm not going to explain you, all the things are given in the chapter itself. You can go through the book, go through the chapter, and you can easily understand the entire concept, friends. So as you saw in the last slide that the installation is very important for the energy conservation point of view. So in this case you see that the thumb rules for cold installation, basically the chilled water pipe installation should be around 2 to 3 inches thickness should be provided to the chilled water pipe. And also duct installation you have to provide 1 to 2 inch of thickness. Then suction line refrigerant pipe installation provide 2 to 3 inch thickness. So this is the thumb rule for cold installation. You should keep in mind, basically, so this you cannot expect too much of questions from this part of the chapter, but still if they ask you to explain the cold installation part, so these are the thumb rules can be highlighted in the expression during the exam, friends. Again, this is very important point for you to understand, friends, the efficient operation and the maintenance of the refrigeration systems. So basically, here are some of the points listed here, which is very important for you to learn, to understand, and also to keep in mind. Basically, they may be asked in the examination. They may ask you to explain the how you can efficiently operate and maintain the refrigeration systems. So these are the points you can at that time can highlight and explain in detail also, friends. The suction temperature, pressure, delivery pressure of the compressor should be kept at optimal level. Ensure all indicators are working properly. Keep record of oil consumption. This is also very important. In the case of condenser, you can see you remove scale and algae, adopt suitable water treatment. Give periodic purging of non-condensable gases. Lesser the water temperature, more the COP. Routine defrosting of cooling coils. Stop condenser water pump when compressor not working. 5 degrees centigrade rise in condensing temperature increases 10% power consumption. So you can see here as the you know uh, increase in condensing temperature will have increase in power consumption. So you have to keep the condensing temperature as low as possible. Again, 5 degrees centigrade in evaporating temperature decreases 10% of power consumption. So if there is increase in evaporating temperature, so you will have the less power consumption. So you have to keep the uh, evaporating temperature as high as possible. That's what we saw in the other slides. So this is very important concept also, and also as far as the maintenance and operation is concerned, so you have to keep these things in mind, so you can explain in detail or at least briefly these points, some of the points which are highlighted here and listed here, friends. Also continuing the energy saving measures in refrigeration system, friends. So basically in broad ways, two broad ways by which you can explain this to this particular point, friends, in the case of examination. So first one is by decreasing the load, and one is the by optimizing the refrigeration system. These are the two broad ways by which you can conserve energy in the case of refrigeration system, friends. So you can explain these 2 points in detail if they ask you to explain in broad ways by which you can save energy in the case of refrigeration system, friends. Also, there are some other points which are highlighted here. Basically, the energy saving measures in FSS system, friends. So look for process modifications to reduce the cooling load. Use cooling water to remove the maximum heat before using chilled water. Provide VSD for condenser water pumps and avoid primary pump operations. So these are some of the I'm not going to explain you in detail here. This is only for your understanding and for you to remember. Not all the points are important to understand, or you can say remember. At least 5 to 6 points you can key points you can understand and you can remember, and that can be explained in brief, or you can say in detail also as per the questions asked in the examination. So they may ask you to briefly explain or in detail explain the energy saving measures that can be taken in the case of refrigeration system, friends. So you can at least 5 to 6 you must remember, and you can just jot down the points and also explain in brief in the case of examination, friends. So it's very important for you to understand as far as the examination concerned, friends. So that's it. This is the end of the chapter, friends. Basically, the chapter in the refrigeration system. I hope this is very useful for you to prepare the exam, and may help you to crack the exam in a better way, friends. So if not done till date, please subscribe my channel, and also please like press the bell icon so that you get the notification as soon as I post a new video in coming days. Also, please share among your colleagues and whoever you think is important for them to understand and the concepts for the examination and may help to prepare the examination in this year or in coming years. Please share these videos, and you can also watch the other videos that I have posted on different chapters, and also numericals. I am going to prepare separate videos on numericals and important concepts. So keep watching the videos, and please do subscribe my channel, press the bell icon, and also please share among your friends. So that's all for today, and let's meet on a different chapter on a new video in coming days, friends. Thanks for watching the video.